Hi guys, welcome to Prison Realm, and in this video we're going to be looking at another question under the topic of electric forces in the electric fields. So this is one question with two parts, part A and part B. Part A says, what must the charge, which is the sign and the magnitude of a particle of mass 1.43 grams, be for it to remain stationary when placed in a downward directed electric field of magnitude 660 newtons per coulomb? So you must understand that they're not only asking us to find the magnitude, but they're also asking us to find the sign, which is very important because we need to know, is it going to be positive or is it going to be negatively charged? And I'm going to show you how to determine that. So the easiest way to determine that is to understand that they said something very important in the question. They said the electric field is directed downward. And if you remember from our previous video, I taught you that for positive charges, the electric field projects outward. It goes outward from the charge. But for negative charges, the electric fields move inward towards them. Okay? So we need to find a way in which we can manipulate this knowledge about this and form electric fields that move downwards. What I mean is this. Since we understand that for positive charges, the electric field moves outward, that means if we put a positive charge over here, we'll have an electric field projected downward, as the question says. Or if we want to, we can put a negative charge at the bottom, and then we understand that for negative charges, their electric fields move towards them, and you see that in both cases we will have an electric field that is projected downwards. So it is either you put a positive charge at the top or you put a negative charge at the bottom. So either way, I'm going to show you how to solve this question using both scenarios. So let's first start with where we put the positive charges at the top. So we have the electric field being projected downward. Okay. So let's say scenario 1, we have something like that. Just draw that properly. Okay, so we label this as a positively charged or surface or anything, and this is scenario 1. And we understand that for such, the electric field is projected outward, so it is projected downward in this case. Okay, and then we understand that this particle should be stationary in this electric field. Okay, like that. So what charge could this particle be? Could it be positively charged, or would it be negatively charged? So for this particle to remain stationary, we must also understand that this particle has weight, because they gave us the mass. They said it is 1.43 grams. It has weight, and weight is always projected vertically downwards. Okay, so this is our weight, mg, downwards. That means we already have a force pulling it downwards, vertically downwards. For this to be stable or in equilibrium, we need to have another force pulling it upward. And guess what? Since we're looking at electric forces, obviously, the only force left that could cancel out the weight is the electric force itself. So since the upper part is positive, this should be negatively charged for it to experience a force upward. Remember that opposite charges attract while like charges repel. So since this ball, this particle will be negatively charged and the upper part is positively charged, there will be an attraction between those two surfaces. Therefore, we now have a downward force of weight and an upward electric force. Okay. Okay. And we have, that's the electric force. And the equation of the electric force in this case is equal to, the electric force is equal to the charge of the same particle there multiplied by the electric field that it is in. And remember we said that this should be negatively charged. Okay, so in this case the upward force is just QE. Now we're going somewhere and we have been asked to find the charge. Pardon me. We've been asked to find this charge over here, which can easily be done. But before we do so, I want to show you how we can use the second scenario now. So scenario 2, and in scenario 2 we'll have negative charges at the bottom. Okay, like that. Then the electric field in this case will still also be directed downwards. So I'm just doing this to show you that it doesn't really matter which scenario you choose, but as long as the electric field is directed in the direction mentioned in the question. Okay, so we have the particles were there. Okay, so now remember in scenario 1 we said this particle should be negatively charged. Okay, let's see what charge it will be in this scenario 2. First of all, we have weight, which is always directed vertically downwards. Okay, so now we already know that there is motion downwards. Now they said this particle should remain stationary. That means we need another force that should direct it upward. Okay, we already have mg downwards. What force could direct it upwards? And of course, as I mentioned earlier, we're dealing with electric forces, so this force should be an electric force as well. So now, in what case would we have an electric force that pushes this particle upward? It is only when there is repulsion. Okay, it is only when there is repulsion, because the bottom is negatively charged. So if this guy, the particle, is also negatively charged, then there would be a force repelling it upwards. Okay, so the force that we'll have there is a repulsion force. So you see that in both cases the particle is negatively charged. So this is just to show that it doesn't matter which scenario you choose, as long as the electric field is directed in the direction mentioned in the question. Okay, so we know the sign. First thing done. So now we need to find what's the magnitude of the charge. Okay, so we can just equate, because we know that the summation of forces in the y is 0. Summation of forces in the y is 0, but in the same way we have QE, which is upward, and it is going in the positive direction, so it is positive. And we have mg going downwards in the negative y direction. And because these two forces are equal, that means the summation of those two forces will give us 0. So from this we know that we can have this equation: QE is equal to mg, which makes sense because for this to be stationary, for this charge to be stationary, the upward force must be equal to the downward force. Otherwise, if one force was greater than the other, there would be motion in the direction of the greater force. Okay, so since we're trying to find Q, let's make Q the subject of the formula. So we know that Q will be equal to mg divided by E. And the mass of the particle should be in kgs, of course, kilograms, and we have it in grams, so we need to divide it by 1,000. And we will have 1.43 times 10 to the power negative 3 multiplied by, and remember that's kgs, multiplied by 9.8, like 9.8 meters per second squared. And this is divided by the electric field, which we were given 660 newtons per coulomb. Therefore, we see that the charge will therefore be, remember the sign is negative, so we have negative 2.12 times 10 to the power negative 5 coulombs. And that right there is the sign and the magnitude. See how easy that was? Yeah. That's our answer right there. Okay. So let's go to part 2 now, which is the last part. Part 2 says, what is, I'm reading part 2 here. Part 2 says, what is the magnitude of an electric field in which the electric force on a proton is equal to the magnitude of its weight? Okay, part 2 is easy. This is part 2. They said the magnitude of the electric force is equal in magnitude to the weight of a proton. Okay, and we've been asked to find the electric field. So we know that the electric force is just simply the charge. The electric force on a proton is just simply the charge of that proton multiplied by the electric field that it is in, and the weight of the proton is just equal to the mass of the proton multiplied by the acceleration due to gravity. And we've been asked to find the electric field. So making the electric field the subject of the formula, we have that. Okay, and now the mass of a proton is constant, and so is its charge. So you see we have everything that we need here. We know acceleration due to gravity, the mass of a proton is constant, and so is the charge of a proton. So the mass of a proton is 1.6 times 10 to the power negative 27. Then the acceleration due to gravity is 9.8, and the charge of a proton is 1.6 times 10 to the power negative 19. And punching this into the calculator, we get okay, we find that the electric field in this case is equal to 1.02 multiplied by 10 to the power -7. And that right there is the answer that we've been waiting for. Okay, so this is the end of this video. Thank you guys for watching. Make sure to like, share, subscribe, and just to turn on the notification bell so that you get notifications each time I post a new video. Thank you guys for watching, and see you in the next video.